بي اوريدي سعادتك؟
جاهز يا فندم.
طيب يعني سعادتك نفتح الكاميرا يا فندم ولا حضرتك مش عايز تفتحها؟
افتحها يا فندم، افتحها
بعد اذن سعادتك.
وادي الشير بتاعي.
تسلم يا استاذ. بسم الله الرحمن الرحيم. هو يسعدنا طبعا ان يكون معانا النهارده استاذنا الغالي استاذ دكتور بهاء بقرنة في يعني احد محاضراته الممتعه المميزه، محاضره في البيزكس اوف ذا بيزكس اللي هي evaluations of plates and screws. يعني اعتقد دي محاضره ما فيش دكتور عظام المفروض ما يكونش يسمعها، ومفروض يعني جميع دكاتره العظام يكون عندهم يعني يعني very big knowledge and very big background على evaluation of plates and screws. دكتور بهاء بيه كان ابتدى سلسله المحاضرات دي بالنيلز interlocking nails، ودلوقتي هنكمل بالبليتس اند سكروز. دكتور بهاء بيه طبعا حضرتك مشرفنا ومنورنا يا فندم.
الله يخليك يا دكتور محمد، ده شرف لينا طبعا، وبنشكرك على المجهود العظيم اللي انت عامله في كونتينوس ميديكال اديوكيشن دوت. دي حاجه جميله جدا يعني ان احنا نبقى على اتصال حتى في وجود عدم وجودنا فيزيكال يعني، لكن دي حاجه جميله جدا ونشكرك عليها.
ربنا يخليك يا استاذ.
هبتدي الشير.
اتفضل يا فندم.
بانت كده عند حضرتك؟
واضحه سعادتك يا فندم. تمام.
بسم الله الرحمن
الرحيم.
It's my talk today about the plate and the screw evolutions and the biomechanics. First of all, this is my objective and the goal of my talk about we code for the history, developmental and evolution, type and classification of the plate and the screws, biomechanic indication, contraindication, special circumstances, and recent advances. If we go to the history, the first use of this metal wiring was by ancient Greek. Then the first recording use of metal wiring in 1755 in the French journal. In 1870, Bergens began writing a book about the internal fixation. In 1877, Joseph Lester, the British assistant surgeon, tried his technique and using antiseptic for surgery. Then Karl Hansmann, a German in Hamburg in 1858, creating making the first successful plate using nickel sheets and screws. In 1892, when Land first introduced the metal plate for using internal fixation. Subsequently, Lambutu in 1905 and then Sherman in 1912 introduces their internal fixation plate. Then Lambudi, the father of internal fixation, considered as a father and the kind of osteosynthesis. In 1948, eagle plate was introduced, and in 1949, Robert Denny designed the first compression plate called co-optier. In 1950, where Mueller formed the AOSIF, the Association of Study of Internal Fixation, introduced the modern orthopedic plating. In 1958, Borghi and Jean described the plate with a special design overhaul. And this is a Rugby plate in 1956. Then Mueller and other in 1965 presented another design that permit interfragmental compression. The blade have a heavier and thicker, is 4.5 millimeters than those designed by Eagle. In 1969, Mueller and Matthew evolved the DCP, and then introduces the low contact DCP was introduced in 1980. In 1987, Beer and Tepik new concept of biological fixation. So what is the goal of operative fracture fixation? The goal of this operative fracture fixation is to stabilize the fracture bone, to enable fast healing and injured bone, return early mobility and full function of the injured extremities. What is the goal of the fracture management? When you do management of this fracture, you are aiming to decrease the pain of this patient, correct the deformity of the fracture, and increase the chance of the fracture healing. And why using implant? The using of the implant to provide a temporary support for the fracture to heal, to maintain the alignment during the fracture healing, and to allow for a functional rehabilitation. What about biological and biomechanical on the fracture healing? Fracture bone need a certain degree of immobilization, which is called mechanical stability, optimum preservation of the blood supply, and biological or hormonal stimulus in order to unite. So the prerequisites for fracture healing is biological and stability. So the prerequisites for bone healing is adequate blood supply. This means that biology, and adequate mechanical stability, which means stability of the fractures. So the fracture management, we have three fundamental principles for the fracture treatment. You have to reduce or reduction if necessary, embolization if necessary, rehabilitation if necessary. So this is the goal of the fixation, the reduction of the bone fragment, stabilization or stable fixation, preservation of the blood supply, and then early function mobilization. So the mode of the fracture healing either by primary or secondary. The primary is a contact healing, and the secondary is a gap healing. What about type of fixation? Type of fixation, we have internal and we have an external. Internal, which can be a rigid fixation, directly applied the bone fixations that prevent interfragmental movement, or external non-rigid fixation. Fixation allow for movement between the bone fragment across the fracture line, like interosseous wiring. This is a type of fixation, either rigid or non-rigid. So what is the definition of the plate? The plate is a load-bearing device. It is a bone plate is a thin metal implant used to embolization the bone segment. The mechanical function of the plate is to transmit the force by passing and protects the fracture site, also holding the fracture end in proper alignment until healing occurs. So the fracture fixation can be fixed. We have two systems, either load bearing or load sharing. So the load sharing is if you have a stable fracture with like transverse fracture, so the bone take the force loading shear coming by the force and pass most of the force coming to the bone and less to the plate. But load sharing, when the fracture oblique or transverse along oblique, the bone and the plate sharing the force. Loading bearing, which when we have a gap or defect, so the plate take the loading of this on the plate. The mechanical aspect of the implant is to the strength depend on the cross section and thickness of this implant. The material which is being manufactured, which is like titanium or stainless steel, which is leading to which is responsible for the strength and the stiffness of this metal. Also the plate, bone plate contact, and also the length of the plate and the number of the screw per fragment, and also the last thing is the bone quality. What is the indication of the plating? It's we have many indications for the plating, like pre-articular fracture, intra-articular fracture, metaphyseal fracture, multifragmental fracture, osteoporotic bone fracture, replace the internal the nail fixation, the physeal fracture of the long bone, non-union and delayed union, osteotomies, and the reconstruction of the bone defect. Do we have an contraindication? Yes, we have many contraindications to using the plate, like if you have an acute or chronic or local or systemic infection at the fracture site, or concomitant disease that may impair the fixation of the implant, significant bone demineralization, or poor soft tissue coverage, we cannot apply the plate, inadequate skin or musculotendinous system covering the plate, allergy to the implant material, severely comminuted fracture in which the bone fragments are too small or numerous for adequate or maintain the reduction. Psychologically unsuitable patient, also alcoholic and drug addict, also any patient unwilling to cooperate with the post-operative structure, and sometimes in the pregnancy if you have a metallic allergy. So we have type of plate. We have a conventional plate and we have locking plate. So we'll go through this type of the plate. So the plate design, it is we have a various plate design and be large or small, thicker or thinner, as appropriated to the anatomical site and the load to which they will be subject. Also, the hole in the plate may be designed for locking screw, non-locking screw, locked screw, or either, and designed to facilitate the dynamic compression. Some plates are designed to have reduced the contact area. Reconstruction plates are designed to be easily to contour in complex anatomical location. And there are plates designed for many specific anatomical locations. This is from the design. And this is an example of the plate. Also, the plate variations, we have concave plate, we have compression plate, and we have locking plate. Concave plate, this is in the placing a concave bend in on the plate is useful to transfer in the transverse fracture. Compression plate, working by placing a cortical screw eccentric into an oval hole and producing a compression as the fracture site. And we have locking plate, we have many advanced locking plate, and we'll speak about it in the next slides. So we have a name of the plate, and we have type of the plate, and also we can mention classification of the plate. If we classify the plate according to the shape, we have semi-tubular, or we have 1/3 plate, tubular plate. And if we're looking for the width of the plate, we have a small, we have narrow, and we have broad plate. If we're looking for the shape of the screw hole, we have round or oval holes, or we have surface contact character like low contact plate, intended of site application like condylar plate, or according to the function, and we will speak about the type of the function of the plate. What about the plate contouring? The plate fits the shape of the bone. A plate including a matching patient anatomy, either to maximize option or reducing the implant prominence. The use of flexible template can facilitate the plate contouring. The plate type, we have pre-contoured type plate, which is coming ready-made, or contouring using depending on the desired plate functions. This is the pre-contoured coming, and we called it anatomical plate. The pre-contoured to fit the region they are designed for, but this is for the average patient, and they may still need it to be recontoured to fit individual patient. What about the material we use? We have many kind of material using for manufacture of the plate. We have a titanium, and now we have a new type of titanium and the medical grade stainless steel with 316 LVM, and we have now a new generation of the stainless steel for manufacture of the plate. We have cobalt-based alloy, we have bioceramic, we have metallic composite, and we have polymer, which is bioabsorbable materials. Now we will go for the plate. We have DCP, which is called dynamic compression plate. This plate characterized by having an oval hole. A hole have a sloping form or shoulder. We have a broad, which is 4.5 millimeter for the femur, and we have a narrow and 4.5 millimeter for the tibia, and we have DCP 3.5 millimeter for the forearm. This is the slope form or the shoulder, which allows the sloping of the screw head. An example, and we have two types, eccentric and neutral placement of the screws. And the width, this is the different width and profile. If we have a small, it is 11 millimeter. If the narrow is 13.5, if the broad, we have 17.5 millimeter width. And the profile is 4 millimeter, 5.4, and 5.4 millimeter broad. And using the screws different from 3.7, 3.5, we have 4.5, and also we have 4.5 and 6.5. DCP compression plate, the compression plate as the fracture side, direction always parallel to the plate. We have two things. We have static and dynamic compression can be applied static in the transverse structure, and the dynamic compression plate if we have using it for tension side. Rule of compression increases the construct stability, decrease the gap to be bridging by the new bone, and it is always primary healing and resistant torsion and shearing. This is the rule of compression. How to achieve method of achieving compression? Can we do this by self-compression plate, the converted torque applied to the screw head to the longitudinal compression force, and it can be applied for one hole proximal to or two other hole opposite to the fracture line. So you can use it in uni, which give you about 1 millimeter compression, or you can use two screws in opposite near to the fracture side, giving you about 2 millimeter compression. Also, we have a tension device, the placing between the bone blade and the adjacent bone cortex, and give more than 2 millimeter compression at the fracture side. What about the technique of DCP? The 2 DCP drill guide, we have concentric, which is a neutral, it is in a green color, and it is 1.1 millimeter off center. We have an eccentric, which is loaded, which is coming in golden color, it is 1 millimeter of the center. This gives you a compression for 1 millimeter if you apply one screw distant and one screw proximal to the fracture line, and use it for transverse fracture. For eccentric load, a hole, the arrow on the drill guide must pointing towards the fracture side. When you applying the guide, this guide has an arrow and must be directed to the fracture line. So the eccentric screw placement, in the produce shearing stress on the screw, the force transmitted to the blade producing interfragmental compression, and the screw head at rest. They have an advantage and also the disadvantage. So the problem with the DCP plate is very extensive surgical exposure. You need to expose the bone, high friction between the DCP and the bone, which is affecting the blood supply of the bone, 2,000 to 400 Newton force between the bone and the plate, compromising the circulation, also increase the risk of necrosis of the bone, enhances the risk of delayed union, enhances the risk of non-union, enhances the risk of infection, and also the risk of refracture after removing of the plate. Why the bone getting necrosis? Because the surgical approach, direct manipulation for reduction, over precise cleaning, preparation of for the setting of the implant, stripping of the periosteum, squeezing of the periosteum, reaming of the endosteum. All these will affect the biology of the bone healing. And this is an example which is published in the Journal of Bone and Surgery about the necrosis caused by DCP for about 3 months and 12 months, and 2 sections shows that the bone necrosis by the pressure of the plate on the bone. Also the plate and the nail causing local necrosis. What about the LEC DCP? LEC means that low contact. They try to make less contact or footprint on the bone, so they invited this second generation of the plate. It's called the LEC DCP, the low contact DCP. Scalloping under the side, the blade bone contact, the footprint reduced, so there is no pressure, less pressure of the blade on the bone, so it will not disturb the blood supply. Even distribution of stiffness. Symmetrical hole eccentric placement in either direction. Now we have another type of plate when we're using it like in the flat bone. We have this type of plate, which is called the reconstruction plate or recon plate. We have lengthwise hole with a spherical or conical surface of contact for the screw head. Also, they have a deep notch on each edge, and contouring in all plane can be done by this special device. You can contour it. Overhaul allow dynamic compression for the screws used for fracture with a complex 3D geometry like fracture pelvis, fracture supracondylar, such as pelvic and distal humerus can be used for recon plate. What about another type of plate? We have a tubular plate. This tubes, it's a 1/3 tubular plate, which you can adapt it with 3.5 millimeter. We have semi-tubular plate, which can use by 4.5 millimeter screws. Always this thin plate, its thickness about 1 millimeter. The use area with minimal soft tissue coverage like the ulna. Overhaul eccentric placement of the screws. They have a collar secure plate bone contact which adapted to the bone. Now we are coming for another type which is called the locked plate. This had a screw head has a threaded that locked into the threaded hole in the plate. We are creating a fixed angle at each hole. Theoretically eliminates the individual screw failure and the plate bone contact are not critical. So there is less plate bone contact with locked plate. What about type of locking plate? We have two types mainly. The fixed angle اللي هي monoaxial. This type, it's the locking head screw are engaged in the plate or by the screw through an adapted ring. We have a variable angle or polyaxial locking plate. The screw can be locked with a certain clearance within a coil with an area of angulation order of 1 degree up to 15 degrees. We have another type. This another type is called a non-threaded head screws is locked to the plate via the threaded lock nut into the screw hole. This type, and the screw head is threaded but is spherical in shape and is screwed inside its pilot hole in 4 separate threaded flanges. This type of the screws. What we have, what we call the combi hole. Combi hole. This is a hole can adapt it two screws. What is the combi? The combi hole allow placement of conventional cortical screws and cancellous bone screws on one side, or threaded conical locking screw on the opposite side of each hole. So this type of you can apply the two screws, but the tip and tricks in this one is to apply the locked screw first, then apply the conventional cancellous or cortical screws second one. Locking plate, you must have for locking plate, you must have reduction of the fracture first and the compression done prior to using the locking screws. Because if you are applying locking screws, cannot be compressed or you cannot reduce the fracture. So in the locking plate, you have to reduce first and compressing the fracture and then apply the locking screws. Cannot put cortical screws or lag screws after locking screws. Locking plate increases the axial stability. It is much less likely that an individual screw will fail, but the plate can also still break for this type of locking plate. Locking plate indication of locking plate can be used in many indications. You can use it in osteoporotic bone, metaphyseal fracture with short articular block, or bridging plate. What looking plate is the first generation were considered internal fixation, but they have the plate and the bone was mismatching, and they use unicortical screws which cannot sustain the torsion. Biomechanical advantage of looking plate fixation, the purchase of the screw to the bone not critical, and you can use in osteoporotic patient. Preservation of the periosteal blood supply, so not affected the biology. Strengthening of fixation rely on fixed angle construct of the screw to the blade, not on between the blade and the bone. Also act as internal or external fixation. We have some terminology and we have to know about using wise LCP. We have a screw blade fixation, means that the blade does not need to touch the bone at all, which is of particular advantage in the so-called mini-invasive percutaneous osteosynthesis, MIBO. So MIBO, if we hear about MIBO, MIBO means minimally invasive percutaneous osteosynthesis. What about LISS? LISS, less invasive stabilization system. This type of system can be used in distal LISS for distal femur and for proximal tibia. We have PC fixed point of contact fixator internal, and we have Philus plate. It is used for the proximal humeral internal locking system. And we have also screws. We have self-tapping. We have self-drilling screws. Looking internal fixation can be used for as a conventional plate using only for DCU, as a pure internal fixation using low LHS, or a combination of the above and precaution. And the price for this is two for the price of one. Indication of LCP, they are periarticular fractures, intra-articular fracture, metaphyseal fracture, multifragmental fracture, osteoporotic bone fracture, and the place of nail fixation. What about the claiming of the DCP? Minimally invasive, no loss of reduction, primary or secondary, biological fracture, environmental, preserved, flexible fixation and relative stability, rapid solid union even if with unicortical screw, less infection and refracture rate, less angular stability even for osteoporotic bone for this if you use locking DCP. Looking of the screw put out of the strength is less. What is a MIBO? MIBO, this is using a small incision, little dissection of the soft tissue, and the strapping of the soft tissue also less. Conventional and looking plate can be used for this type of MIBO. Preservation of the osseous and the soft tissue vascularity, very important, which is you preserving the biology, and the healing here is by second intention because this is a relative stability. So the advantage of looking is preserving the blood supply, rapid bone healing, less infection, less intra-operative blood loss, a small incision for this patient. But the disadvantage is a complicated technique, expensive reduction tools needed, excessive demanding, and also need an X-ray, axial and rotation alignment can occur. So the LISS or less invasive stabilization system, this can be used for distal femur or proximal tibia. LISS plate is an internal fixator used as an extramedullary splint, fixed to the two main fragments, leaving the intermediate zone untouched. So the fracture side leaving untouched, so preserving the blood supply. Plate function and type, we can looking for the plate properties. For the plate properties, it depends on the structural properties. The bending rigidity of proportionate to the thickness on to the third power. Titanium has a young modules of elasticity that most closely approximately to the cortical bone. Also depend on blade working distance, and we'll speak about this later. So the biology of the blade depends on absolute stability or relative stability. The absolute stability is the constructs healed with primary low intermembranous version healing, most eliminated the micro motion with large screws fixation, must be low strain at the fracture site with high fixation stiffness. Relative stability, this is the constructs healed with secondary and dorsal healing, and the strain rate must be about 10% or 5% will be predominant. What about the blade function? If you ask it about the blade, can you use this blade? What is the function of this blade? This blade can be used as a compression, can be used as a buttress plate or tension plate, or anti-gliding, or span plate, or bridging plate, or protection plate. If the examiner gives a blade, telling you what is the function of this plate, this is the main function of the plate. But if they give you an X-ray with the plate applied, they asking about the module of the bone plating, the module of using this compression modules or neutralization modules or buttress plate, anti-gliding plate, span or bridging plate or tension plate. So what does the mean compression mode? Compression mean bringing the two fragments close to each other so that the fragment oppose well. When the plate is used to achieve compression in the fixation of the fracture, is said to be used in compression mode. This mode is used only in transverse fracture and also in oblique fracture, which can be compressed. Compression plate اللي هي need a reduction and compression and also transverse or oblique fracture. Unable to use the leg screws. What about how we can increase the compression across the fracture site? We have method of achieving compression. We can use with tension device. We can use overbending. We can use DCB or low contact DCB principle, and we will mention it later. And the contouring of the blade can be achieving a compression or additional leg screws through the blade. Also, you can achieve more compression. So this is the example of the 3.5 millimeter plate, low contact dynamic compression plate, strong and stiffer, more difficult to contour, usually used in the treatment of radius and ulnar. Semitubular plate, very malleable, limited strength, most often used in the treatment of fracture. So the compression, fundamental concept, criteria for the primary bone healing. Compression bone fragment decrease the gap and maintains the blood and the bone position even when physiological loading is applied. Achieves through the leg screw or the blade technique. So this is the method, and we will go through it, how we use tension device, overbending, DCP plate or LC DCP plate principle, contouring of the blade, additional leg screw through the blade. This is the screw device, compression low tension device. Required a separate drill screw hole beyond the blade. You make one screw outside the blade and you apply this device, which is called tension device. And the concept of anatomical reduction with added stability by compression to promote the primary bone healing where has not changes. So this is applying the screws distal to the fracture site and the tension device proximal to the fracture site, and then by compression you introduce a compression at the fracture site. Currently more commonly used with indirect fracture reduction technique. This is the blade pre-bending compression, overbending. We can use this technique, pre-bending plate, and a small angle is bended into the blade center as a fracture site. If you have a pre-bending, so when you're applying the device, there is a big compression as the far part of the fracture line. Then when you are tightening the compression device, the tension will be for the nearby the plate. The plate applied and the pre-bending plate compressing to the bone, the plate went to the straight and the force opposite the cortex into compression. Near cortex is compressed via standard vessel. This is an example of the compression device. Dynamic compression plate, this is using the DCP hole, and this is by applying eccentric hole, one proximal to the fracture side and one distal to the fracture side, and this will give you about 2 millimeter compression at the fracture end. Dynamic compression plate, this is applying via oval hole and eccentric drill, as we mentioned about the device before, and the arrow must be in, directly to do the fracture, directly to do the direction of the fracture line. This is the leg through the plate layer by compressing can achieve and the rigidity obtained all with one construct. The compression plate first, then leg screw placed through the plate if fixed allowed. This is the compression plate design, how the screw applied and the sliding and the mechanical compression to the fracture line. Compression plate bending, this is the two type of the pre-bending. Without pre-bending, the plate, there will be compression under the plate and destruction on the opposite side. This one without bending, so there will be compression here. By applying a compression, there will be inducing this pre-bending and this without bending. So there will be compression this away from the fracture line and near the plate. Pre-bending resulting in eventually distribution force across the fracture side. Compression tension device is very important to know the direction of the fracture. The compression of an oblique fracture must be performed in such a way that the loose fracture fragment locking into the axial load. Look for this fracture. This is an oblique fracture. If we make a compression, then will be locked here and the fracture will be stable and the compression reduced. But if making the opposite way, the fracture will be slide, the bone will be slide and will be no compression. So this this one in the plate, the axial of the plate bone construct, otherwise it will lead to mal reductions. When the leg screw is placed through the compression plate, compressed with the plate first, parallel to the leg screw. So if you go and make an interfragmental screw through the plate, first locking the screw first, then apply the interfragmental screw through the plate. The other mode of the plate function is using neutralization mode. In this type, the plate, the leg screw is used to neutralizing to prevent the bending and bending shear and rotation force. The neutralization plate can be placed to support the leg screw. If you have a leg screw needed to support, otherwise the leg screw cannot sustain the force on the bone. Help resist the torsion and the shearing and the bending. Serves as a splint for the leg screw. Leg screw can be placed through the plate to avoid additional stripping. X obliquely fracture, like for forearm and fibula, order of fixation is very important. This is an example of neutralization plate. The neutralization, which means that protecting the leg screw from shearing, bending, and the torsional force across the fracture. And always remember the bone protecting. You have protects the plate. You have protection plate here. This is a plate to protect the interfragmental screw from loosening. This is an example of neutralization plate. If applying leg screws, cannot sustain any pressure or any force, so put the plate to neutralization and to help and to protect the leg screws. What about buttress plate? Buttress is to support or reinforcement to the wall or the construct. A buttress plate is used to prevent a collapse in the fracture, applied on the compressive surface of the bone, used around the joint like proximal tibia, and prevented the deformity under the axial load. And there is a special shaped plate for the most common anatomical buttressing required, and this makes application of the plate easier. This is an example of buttress or anti-gliding plate. The buttress means holding the bone up. Resists the shearing force during the axial load, used in metaphyseal area to support the intra-articular fracture, and the plate must match the contour of the bone to truly providing buttress effect. This it must be contoured and to take the shape of the bone, like for the proximal or the tibia plateau. Anti-gliding or buttressing concept, the plate is secured by 3 black screws distal to the red fracture line. Axial load causing proximal fragment to move distally and to lift along the fracture line. Plate buttressing the proximal fragment prevent it from sliding. Buttress plate, when applied to the intra-articular fracture, is called buttress plate. But when applied to the diaphyseal fracture, it is called anti-gliding plate. This is an example, order of fixation. Allows the articular surface compressed with bone forceps and the provisional fixation with the K wire. Then applying the buttress plate and applying the 3 cortical in the bottom, the 3 cortical screws, placing providing buttressing effect. Then the top 2 partial threaded cancellous screw placement, they make with large leg articular surface together. And the third screw placement either in the leg or normal fashion since the articular surface already compressed. Anti-gliding, it is the anti-gliding plate, as we all mentioned that in the diaphyseal fracture. In anti-gliding plate, the plate is fixed to the bone in such a way that it prevents the distal fragment from overriding when the force is applied along the long axis of the bone. The distal fragment is firmly wedged between the plate and the fracture surface of the proximal plate. The distal fibula, it can be called a variation of compression plate. A span plate or bridging plate. What do you mean by span plate? Span plate that you are passing the fracture side. You are not interfere with the fracture hematoma or the fracture itself. Always used in combinations and also an example of the splint fixed to the 2 main fragments, leaving the intermediate fracture zone untouched. Anatomical reduction of the intramedullary fragment is not necessary. Avoiding the advantage of this is avoiding devitalization of the fragment, and always this type, when you are going to apply, you need an X-ray control or the C-arm imaging intensified to check about the position and the reduction of the fracture. Promote the formation of the preosteal callus, so the healing is by second intention. In this basis, the blade, furthermore, screw in the blade are applied. Diamond, we have to apply the proximal screws and the distal screws first, then apply the other screws after that. This is why we call the bridging plate, the bridging or bypasses the convolution. Proximal and distal fixation first, then leaving the fracture bone and the fracture side untouched. The goal is maintain the length, maintain the rotational and axial alignment, avoid the soft tissue disruption at the fracture site, and maintain the fracture blood supply and to reducing the secondary collapse. This is a bridging plate, restores the length, restores the alignment, restores the rotation, and respect the fragment biology, not interfere with the blood supply of the fractures bones. This is an example of a bridging plate after healing. What about tension band? We can use the blade as a tension band. A blade can also be solely used as a tension band apparatus. The blade is attached to the tension side of the fracture converts the tension force into a compression force. You can use it in the femur, and you can use it in the patella, and you can use it in the olecranon. This is an example of tension band blade. The principle of tension band theories is a fixation on the opposite side from the articular surface provided reduction and the compression force at the joint by converting the bending force into a compression. The fracture has tension force applied to the muscle, applied by the muscle, and the load bearing. The tension band preventing this distraction, and the force is converted into compression. This is classical tension band in the olecranon, and all we use it as a tension band. The wire can use for the tension band as well on the olecranon and on the patella, using a 2K wire from the tip of the cranium across the fracture side into the anterior cortex to maintain the initial reduction and ensuring for the tension. What about the working length of the blade? The working length of the blade is very important for the stability of the fracture and healing. So this the definition of this is the distance between the proximal and this distal screw to the fracture. This is the distance between the proximal and distal screw into the fracture side. Well, the blade stress within the short working length is higher, and the blade stress within the long working length is lower. Biomechanical, for the blade fixation, the screw closest to the fracture sees the most force on the construct. The construct rigidity decrease as the distance between the innermost screws increase. What about the length of the construct layer? Longer spread with less screws. Every other rules in layer, if you have 3 screws, use with 5 hole, use 1, 3, 5. 50% of the screw hole fill, and avoiding too rigid construct. The blade span ratio and the blade density, proper implant length, and the type of the number of the screw is essential to obtain a sound fixation with a high blade span ratio and low blade screw density. This is a very important concept when you are applying for the blade. So what we mean by blade span? The blade span ratio is the ratio between the fracture length and the blade length. The more you have the fracture length, the more you need the blade. So the higher blade span ratio decreases the load on the blade. If you have a fracture with a multiple fragment fracture, so you use a blade 3 times longer than the overall the fracture area. If you have a fracture like 5 centimeters, you need to use a blade with 15 centimeters. But for the simple transverse fracture blade, the length is 8 to 10 times the fracture length. What is the blade screw density is a quotation formed by the number of the screw inserted into the number of the blade hole. If we are in summary, if you're looking for this type, the distal one, we have 3 holes, and we applied the 3 screws. This is the blade screw density is 0.75 if multiplied. It was the number of the screw and the number of the hole. This is the blade length, and the fracture length. This is in comminuted fracture. The blade length should be 2 to 3 times higher than the overall fracture length. We have to remember this quotation. And for the transverse fracture, a simple fracture, this ratio should raise to a value of 8 to 10 times the fracture line. So for Simplicity for the biomechanics, the number of the screw, cortical screw recommended on each side of the fracture. For the forearm, you need at least three screws proximal and three screws distal to the fracture. And the humerus, you need about 4. So the number of the screws go to up to 8. For the tibia, you need 4 screws proximal and distal. Means that you need, for the plate, you need 8 screws. For the femur, you need more from 4 to 5. Means that 8 screws at least in the plate. Biomechanical, this is rules, the strength of the blade against the number of the screw and the space. We use 1, 3, 4 instead of 1, 2, 3. Torsion strength, the number of the screw, but not the space between the screws. Now we go for the next part, which is the screw types. We have many types of the screws using in the orthopedic field. We have a conventional screws, which can be divided into cancellous and cortical. We have headless screw. We have single versus double head threaded screws. We have solid and we have cannulated. We have locked and we have non-locked screws. We have locking screw head locked into the blade, creating a fixed angle devices, and can be cortical, cancellous, solid, or cannulated. So the character of these screws can all these screws can be either non-self-tapping or self-tapping, ST, or self-drilling, SCD, or self-tapping and self-drilling. Those screw is a screw definition is a cylindrical with a spiral threaded running on its outer surface. It converts the torsional force into a compression force. Function is to dispute and distributing the mechanical force, conventional rotational force into linear motion. The screws consist of 4 parts: head, shaft, thread, and tips. The head, which is suitable for screwdriver attached, and the counter force. Cancellous can be used, screws can be used for soft bone. Vertical can be used for large root diameter. So the biomechanical is the screw fixation, the screw anatomy. You have to know about the inner diameter, the outer diameter, and the pitch of the screws. The difference from each other makes the screw different. It's cortical or cancellous. So to increase the strength of the screw and resistance the fatigue, you increase the inner root diameter. That makes the root very thick. So this, which can be used in the cortical screw. To increase the pull pulling of the strength of the screw, increase the outer diameter, decrease the inner core, increase the threaded, increase the thickness and use the cortex with more dense. This is the cancellous screws. Cortical screws can be almost fully threaded, a small pitch and greater number of the thread. So it is a small pitch of the thread and with a great number of the thread. The thread diameter is equal to the core diameter. The thread diameter less than the core diameter. The core diameter is less. Used in the position or lagging diameter, we have 1.5, we have 2, we have 2.7, we have 3.5, and we have 4.5 millimeter, and we have another 6 millimeter for cortical force. Cancellous screw creating threaded depths, and this gives you a better purchase. Always have a large pitch, and thread diameter to the core diameter ratio is more. The diameter is 6.5 and 4.5 millimeter. The core diameter is 2.2 millimeter or 1.9 millimeters. Designed to have a better purchase in the cancellous bone. We have a fully threaded, we have partial threaded, and this partial threaded can be either 16 millimeter or 32 millimeter. Always we have non-cannulated and we have cannulated cancellous screws. Biomechanical of the screw fixation, the cannulated screw increase the inner diameter required, relatively smaller thread widths resulting in lower pull-out strength. The screw strength minimally affected. We have screw, what we call self-tapping screw. This means that needed pre-drilling to a pilot hole, but creating its own thread in the cortical bone by virtue of the cutting flute as the tip. Has a cutting tip that enables to cut its own female threaded track as it's being inserted. Remove the bone debris and the threaded forming a cutting. What about self-drilling? It requires no preparation for the bone before insertion. It is also self-tabbing, eliminating the needed for pilot hole, but can tab as well. No preparation of the bone before insertion. Also, can be self-tabbing. Cannulated screw, and cannulated screw, this type of screw, it is a cannulated or hole to allow them to places over a guide wire. Period to drilling or screw insertion. Fully and partial threaded screw is available and is different than. We have a special screws like has a different pitch screws, Herbert screw, self-compression, double pitch screws can be used, and these are usually cannulated. Locking plate screws. What is the locking plate screws? This is the screws used for fixation of locked plate. Has a locked head screws, have a large core diameter and the thread with a blunt edge. Thread head or locked head. Engage in the plate and the plate is not pressed against the bone. The screw locked into thread plate hole. Angular stability constructed by these locked plate screws. Plate screws, this is the ordinary plate screws which use, it is non-locking screws, fixed plate to the bone, placed centrally or eccentric. We have another type of plate can be used, positional screws. Can be used like, for instance, Moses screws or fully threaded screws tapped in both cortex, no compression. The screw has neutral effect on the fracture fragment position. Pilot hole diameter is slightly greater than the screw core diameter. We have lock screw. Lock screw, this is the screw used for interlocking nail to lock the nail. And we have a pilot screws used in redirection of intramedullary nail, as we mentioned before. Lag screw and interfragmental compression, both fully threaded and partially threaded screw can have a lag effect. We have anchor screws. This is used for using for tension band. This is the type of the screws you've been mentioned before. What about the difference between convention and the locked screws? The convention, the tightening of the screw compressing the plate to the bone. So this will affect the blood supply and resulting in friction force keeping the construct stable. This is the conventional screw. But locked screw, the screw head threaded and locked into the plate, creating an angular stability construct. So the plate not needed to be touching the bone. So this helps to preservation of the blood supply. This is different between DCP plate and also low contact DCP. Preservation of the blood supply, less bone pressed during the locked plate, but not in the conventional plate. The bone is pre-stressed and the blossom is struggling and affecting the blood supply. What about locking plate screw biomechanics? We have inserted the locking screw into either unicortical locking screw. You have less torsion, fixation strength than non-locked bicortical screws. And we have bicortical locked screw, have a significant more resistant to all applied force. With this is resistant to torsion, increasing the most increases the most and versus unicortical. Locking plate screw biomechanical, locking plate construct stiffness and stability increase with, if you are needed to increase the stability, of the by increasing by making a bicortical looking screw, increase the number of the screw diversion from the screw hole by 5 degrees, and use long plate. This is the difference between unicortical or bicortical and using in cancellous and normal cortical bone, osteoporotic bone or non-osteoporotic bone. Function on the mechanism of the screw. As we mentioned before, for the plate, the mechanism here, we use the screw as a mechanism of function. We can use as a neutralization screw or leg screw, reduction screw, position screw, anchor screw, locking head screw, lock screw, bowler screw to guide the nail pass into the interlocking screws. Leg screw, as we mentioned, we use used to compress the fracture fragment for interfragmental compression, characterized by absolute stability to the interfragmental compression, need a gliding near cortex, the whole far cortex, وبعدين need a countersunk and the best compression at 90 degrees to the fracture line. Leg screw, the screw compresses both sides of the fracture together. The proximal gliding hole is diameter of the thread. The distal hole is the diameter of shank, best for compression, for shearing, bending, and rotational forces. That is why we need a neutralization plate for the leg screw, leg by technique or by design. The techniques, we have two types of techniques, as we mentioned. The sequential of the leg screw before or after does not matter. Also, long as fundamental are followed, leg through the plate when possible. This is a leg screw can be applied by two types. In a fully threaded screw act as a leg screw when the proximal hole, gliding hole is drilled with the diameter of the screw thread. We can use a leg screw by partial threaded screw, and it can act as a leg screw as long as the thread part does not crossing the fracture line. So this is the leg screw using this technique by full threaded, and this is by partial threaded leg screws. Fully threaded example of 3 mm vertical screws, as mentioned, اللي هي reduce the fracture and drill perpendicular to the oblique fracture line. Making a gliding hole, first one, drilling with the outer diameter of the screw, the 3.5 mm. Then center the drill for the core diameter of the screw, 2.5 mm, within the gliding hole, using the drill sleeve or drill far, countersunk the proximal cortex, improving the screw ball head load transfer, measuring the screw length after the countersunk. This is an example how to apply the leg screws. And the null position of the screw, not countersunk or fracture comminution, can lead to loss of the reduction. This is a leg screw placing perpendicular to the fracture line. Resulting in maximum interfragmental compression. A leg screw inserted perpendicular to the long axis of the bone, resulting in maximum resistance to shear force, reducing during the axial load. This is in the most cases, a single leg screw is not sufficient to stabilizing the force. So within the fracture, especially shearing and torsion force, therefore additional leg screw and or neutralization plate needed to help or to prevent refracture or dislodging of the screws. What about hybrid fixation? Hybrid fixation means that we mentioned about the combi hole, and here we use hybrid fixation. This hybrid fixation is a combined benefit of both standard and locking screws. By recontouring the blade, reduces the bone to the blade and compress and the leg through the blade. Then increase the fixation with locking the screw at the end of the construct. What about the using of the drill bit? We have two types of drill bit. We have two types of the blade of the drill. This is the lip cutting bone. The fluid carry out the shear slightly larger than the minor diameter of the screw. Each cortical screw has a pair. Can we have a major gliding hole and minor threaded hole? And this is in this table. It shows that the diameter of the screw and the drill bit using for the 3.5 millimeter cortical screw, use the drill bit size is 2.5 millimeter and use tab 3.5. For the 4.5 millimeter cortical screw, use 3.2 millimeter drill bit and use the screw 4.5 millimeter. For 4 millimeter cancellous screw, use 2.5 drill bit size and 3.5 millimeter cancellous screws. For the 6.5 millimeter cancellous, use the 3.2 millimeter and use the screw 6.5 millimeter. For manual screw, use the set tapping and 3.2 millimeter drill bit and use the screw 4.5 millimeters. This is an example. Quick coupling and non-quick coupling according to the drill use. Tab, this is the bone tab, is a shaped implant with a threaded end that cut into the bone to facilitate the screw insertion. And it has a cut thread. The tab line, whole center line, and for the technique, you use half back turn after every 2 forward turn. أنت تلف مرتين, then go half back turn to use for the proper way of preparing of tapping. What about the rule of the plating in bone infection? High rate infection, use 6 rules. Rule of the plate in the open fracture, always high rate of infection can be occur. 6-hour rules, if you have a fracture more than 6 hours, don't you make a primary fixation. You can use in Castello 1 and 2. In Castello, in grade 3 wound conditions indicated in the upper extremities and the periarticular and the articular fracture can be used. And this is an example of in a case of infection. What is the plate in the union related problem? If you have non-union or delayed union, delayed and non-union, you can use the plate to enhance the union. Mechanical failure or compression plate corrects the malposition of the plate. Always use angular deformity. Put the plate as in the convex and make it on the fixed and tension side to enhance the bone healing. The plate in situ, this is called the plate augmentation. This plate augmentation used in a condition which have delayed union or non-union or improper fixation like intramedullary vein, and always in a septic condition. You can use it in delayed or non-union. In revision, the plate and the screws, you can use the plate and autogenous bone graft needed. Infected plate osteocesis. If you have a plate which become infected, what is the rule for plate? Is an implant removal? This is a controversy. We have a stable fixation, we have loose implant. So this is what called ICS, infection callus stability classification. This type classifies the condition into 3 types: type 1, type 2, type 3. We'll go through it now. For ICS type 1, there is callus progression. We have a hardware stability in the presence of infection. In this case, you are treating by suppressive antibiotic, local debridement, no hardware needed to be removed. If you have type 2 ICS, it has the presence of infection and the hardware is stable, but no progression of callus. This patient were treated as type 1 patient, but additional callus stimulation therapy needed. In type 3, you show the infection without no callus, and there is a progression and loosening of the hardware stability. This patient need to be underwent removal and exchange of the fixation device. This is the rule for the international classification for standard ICS. Another type of plate is the supracutaneous plating. This is the plating used outside the skin. Can be temporary or permanent external fixator. They claim that they achieve good reduction. They preserve the soft tissue, and you can use for the soft tissue reconstruction. It is a stable fixation and preserving the joint motion and easily to remove as outpatient. What about the plate with indistraction osteogenesis? If you have a patient who is treated by external fixator for distraction by Elizarov or what mono axial fixation, X-fix, so you can use this plate. You can use it as a submuscular plate after completion of the bone distraction, shortening the external fixation time to half, prevent bone grafting and better patient acceptance. Plate and arthrodesis, yes, the plate can be used for arthrodesis, passing the joint, minimize the movement as the arthrodesis side, uses locked and unlock the plate on the tension surface always applied. When to remove the plate removal, why and when? This is a questions you have to ask. No rule after healing. You can remove it or you leave it according to the psychology of the patient. Possible of corrosion, if you have a corrosion, so you have to remove. If they have an inflammatory action, you have to remove. Painful implant, you have to remove. Implant bothering the patient, mechanism like subcutaneous in the clavicle example, needed to be removed. When to remove the plate in the normal ordinary, we have nearly about 24 months after application of the plate. Refraction after the plating is, there is an incidence about 1 to 5% for refraction after removal of the plate. Why? Because there is a plate-induced osteopenia. When applying the plate, it is producing osteopenia, and the bone becomes fragile. The screw hole are weakening point. So this point is a weak point for cannot sustain the force and discontinuity due to the screw removal. This is osteosynthesis fracture. Also can be the plate can be refractions. Plate fatigue and failure. The bone plate is loading bearing device due to repetitive or cycling load and due to the presence of a gap. The plate fatigue occurs in unstable construct, always in unstable construct. In this condition, like severe comminution, if there is a bone loss, poor quality of bone or poor screw technique. And this is always remember the bone protecting the plate. If you have a gap, will be a repetitive or cyclic load, and this will lead to plate fatigue and failure. Take home message: internal fixation allows short hospital stay, enables the patient to return to the function area, and reduce the incidence of non-union and malunion of the bone. Use proper implant for a proper patient. Orthopedic implant become necessary with severe fracture cases. Follow the basic principle: implant should not impede to the natural history of the bone regeneration. This is my reference, and thank you for your attention.
Thank you so much, Professor Bahaa, على المحاضرة الشاملة الجامعة على ال types and biomechanics of plates and screws. I think إن دي محاضرة لازم كل دكتور عظام يسمعها ويستفيد منها يا فندم.
الله يخليك، ربنا يكرمك.
شكرا جزيلا يا فندم. If we have any questions to Professor Bahaa, في حد من الزملاء بيسأل is the webinar recorded? Yes, it's recorded وهتبقى على اليوتيوب channel الخاصة بجمعية جراحة العظام within 2 to 3 days إن شاء الله. Any questions? We are waiting for any questions to Professor Bahaa. When after about 3 days إن شاء الله هتكون موجودة على قناة اليوتيوب الخاصة بجمعية جراحة العظام المصرية. بعد إذن الدكتور بهاء بيه طبعا.
شكرا طبعا، ده أنا بسعيد جدا.
الله يخلي سيادتك يا فندم. Dr. Bahaa, we have a question. What about using locking plates as an external fixator?
We mentioned that. We mentioned
yes.
that We can use it as a supracutaneous, as we mentioned before. You can use it outside the skin.
Yeah. Any other questions? واحنا طبعا بننتهز حضرات ان احنا يعني اليوم الجميل ده ان احنا نهني حضراتكم بقرب قدوم شهر رمضان المبارك. ربنا يعيده علينا جميعا يا رب بكل خير يا رب. We have two questions. Which is better, short working length or long working length of the plates?
لا, short working length is for better. And the nearest to the fracture, the screw has a force, but we need a short distance. This prevents torsion. But the working length, this bending stress more on the plate.
Yes. We have another question. قريب من the same question. Please tell me how long plate far from the fracture. حضرتك قلت الكلام ده يا فندم اوريدي في المحاضره.
قلت ان هو ده اللي هو في الترانسفيرس اللي هو من 8 to من 6 to 8 لينز for that اللي هي 3 times the fracture length.
Yes sir. دكتور محمد بيسأل على presentation على الهاي tibial osteotomy. We have already presentations on high tibial osteotomy. We are recorded على اليوتيوب channel بتاع بنها او بتاع الجمعيه، وان شاء الله برضو نarrange another presentation على الهاي tibial osteotomy يا دكتور محمد باذن الله. If we have any other questions. Okay, يعني at the end Dr. Bahaa, we would like to thank you so much for being with us tonight. Thank you so much sir. وكل عام وحضرتك بألف خير، وإن شاء الله يعني نرى حضراتكم على خير الجمعة القادمة بإذن الله تعالى. شكرا جزيلا دكتور بهاء، وشكرا جزيلا الزملاء الأفاضل، وتصبحوا على ألف خير يا فندم.
كل سنة وانتم طيبين، نص شعبان إن شاء الله، وعايزين بس الناس تبقى تدعي كده وربنا
يا رب. اللهم آمين. اللهم آمين يا رب.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته. شكرا دكتور بهاء، تصبح على ألف خير يا فندم.